Oh, and so the speaker is on this. So let's try not to cuss or say bad things. Roger. It's the Matrix.
Can more than one person?
Huh?
I think you have to hit yes on your phone again.
Oh. Yeah, I was hoping that the Gmail account would stop that from happening, because I don't want to have to, like, in 5 years, if someone's using this account, to be like, tapping yes on my phone.
Right.
You know? Or what if I died, you know?
I don't know what happened.
I don't want it to be
I
intentional.
don't want it to even come up like that, yeah. Yeah, we'll have to figure out an alternative way. For now, don't die.
Right.
You're tied to the club. No dying. Hello. What's that? This side. This side? Okay. Yeah. How are you doing?
All right. Rushing around, I guess.
Oh, yeah.
Just here for now.
Rushing around like a crazy person, huh?
Yeah. I guess getting started is with not having any access to computer internet. It's from till the 9th. And I had to convince people in the department and over at support that this is a problem.
Yeah, it's pretty difficult to teach a class, I would imagine, with no internet.
And they said, oh, we always do this. We shut everything down. And then I said, well, let's look back what happened during the spring, the fall.
Right.
Now, I started working on the class on the 3rd, and school opened on the 18th.
One note, we are live on the internet right now.
Oh, that's great.
So anything you don't want to say about,
I'll continue accordingly.
Right.
I just wanted to put that out there. I just wanted to give you fair warning.
Well, and then,
And everything went up fine. They were very on top of
all right.
it.
And then around the 22nd through the email, Outlook, I got a job offer. So if everything was the same, I couldn't have got started till the January 18th or so. But I wouldn't have got the job offer anyway, because it was submitted through the university Outlook system. So it had to be corrected somehow. And there are a lot of other adjuncts who are in the same position.
Yeah. There's glaring problems with a lot of things.
I guess
Pressing the button.
ostensibly, a lot of people in, I guess, in the business office said, well, I'm moving on. And then they were shorthanded, or they introduced new security measures. So,
Delta, Lisa.
Yeah, that two-factor thing is so annoying. Every time you log into
time.
Outlook or Blackboard with it has to send you a text message or an email, or you have to use the duo thing.
lose the connections at home, so.
Yeah.
Even if you use the same computer at the school and say, remember me for 30 days,
Yeah.
it does not remember you. Hi, what's up, Mike?
Glad to be here.
Tyler.
Yeah, that's T. Lizzie over there. Tyler Lucio. Tyler, your new nickname is T. Lizzie. Only because you said no cap to me the other day.
That's what the kids say.
I don't do it. I don't do it.
after the 9th, everything was behind, and I keep on getting notices like, you gotta fill this out, you gotta install this, and you gotta install that, and it's overdue.
Yeah, I had problems with my Blackboard last semester, or my email and my Blackboard, because I was working here, so they gave me 2 email addresses, one work one and one student one.
Yeah, I could have warned you about that.
And then, so, like, I had to be logged into one, right?
Yeah.
But I still got messages in the other one, but I was missing stuff in my student email from my professors. And so what I had to do was I had to forward everything to one of them. So somehow I was getting double emails for everything. And so like if an instructor added something and deleted something and added something, I'd get like 15 emails. And so it was just a list. I was just getting so frustrated. I've given up on emails. I didn't really check it.
Well, you can't do that either.
New Jersey, right?
But I mean, it's not, possibly, you could start the class to say, how many of you are student employees?
I can definitely find it,
So
but
that was recurring.
what would you say, like a restaurant, like, don't y'all have like a fast food?
They told me, well, there's nothing we can do about it. That's just how it is. I was like, that's just how, you guys are OIT. What do you
You're
mean?
the people who make it how it is. You just like the best.
When the revolution comes, they'll be the first ones up against the wall.
Yeah, right?
That was one of the factors I had in
Bergen?
not working here.
Bergen, whatever.
It literally screwed me on part of my grade in some of my classes.
Go
Not
to
being prepared.
Fort Lee, K-Town. Working with that. That's all I know, to be honest, because I
I
don't.
finally did figure out how to not get like 20 emails at a time from Blackboard about
Travels anywhere, he always tell me like a month.
yeah, like go into Blackboard and
Yeah, I'm
like
gonna go
change the settings.
Where else does he go to? New Orleans.
Notifications on.
I like to make a PowerPoint presentation. Places to go, restaurants to eat, fun things to do, viewpoints.
Like 8 emails.
Yeah,
It's
because
like,
anytime there's like an because I tell them if I travel, I like to know beforehand.
You go to New Jersey, New Jersey now?
Oh, yeah.
Yeah, I don't know where, but he's in.
the cop today.
That's
Finishing.
that's like 90% of the emails I get. The clock thing, the free vintage,
Giraffes.
shuttle run.
Lions.
That one actually is important.
They have
Not
lots
to
of-
me.
Well, no,
I
but.
wish I could turn it off.
Well, we-
Right.
I actually used to have Astro
Well,
World.
and he's- we haven't been
I was
in
like,
San Antonio
can I
in
stop getting these emails? Because it's spam at this point. They're like, you're signed up for school emails, you have to get them.
months.
Make it an amusement park. Any other
Well, get used to the
Oh,
brings
oh,
jobs.
oh, so I want to let it, like
right.
a nice shopping mall. The biggest mall in the US is the American Dream Mall. It's in New Jersey.
And ask at the end, and before it lets you go, wouldn't it?
Gallery mall?
Yes.
Much of an attaboy is a software PhD.
Right. See that?
I don't. Not lie.
Talked a little bit
Atlantic City.
to Austin about tonight. Ask about presentations and so
See, I don't gamble, so I can't really say because I haven't had like the series.
Lunar stuff, I'm not sure if it was
My hands are
night
oily.
Yeah, are you presenting tonight?
I said something, like, present something that.
I'm a place that accepts Apple Pay. What is it?
It's one possibility, and then all of a sudden, out of the blue,
Yeah.
finally figured out how gravitational lenses work.
Oh, you're right. That must be nice.
Started to go out to about 550 AUs out from the sun. We'll set up a telescope out there.
Can you imagine how pissed that? Can you-
Oh.
It's kind of unwieldy. I guess you gotta pick the one you want to look at.
Unless the students live in the apartments,
I just don't understand.
it'll be even better if
It's slowly
That's
coming
why I
together.
love that because it's close
I think the
enough.
remaining issue is saying the sun is like a
Never
cone,
been late to class.
blotted out, and you see around the edges. The point source it's all lined up. It'll come across
Why don't you just move
the
to
edges
the
and be really.
Their apartments are
mild.
cheaper.
So there's some type of convolution or Fourier transform. It's going to do the trick. That part I don't
freedom of
understand.
space, you get your own, you can't go in
The
the
other
morning,
part's
they have
leading
a curfew,
Because that
Really?
seems like an odd,
10 o'clock.
Yeah.
you have a coronavirus.
Wow, that sucks.
It's done.
Mm.
But man, traffic is so bad. It's
There's all this
9:59.
information that's
After 10 o'clock, can't
coming
get in,
from
can't get out.
Let's say general relativity.
Mm.
They're not
It's
screaming.
550 AUs, and it comes back together.
Like,
You can't see what's on the other side, so it's slipping around the edges.
Alright.
Yeah, and then they're
And then how much of that,
based on like how much it's distorted, they're like,
yeah, there's a distortion of a sort, just from the sun being in the way.
yeah.
And then you get it and say, well, I
$15
can
difference, right?
a zillion times.
This is
Because
the
the
And
idea
then
is,
like reconstructed in, oh wow.
UFA, right?
suppose they get down to 10
205,
kilometer
right?
resolution.
This is the
for
water.
Planet.
One bed, one bath, walls, everything,
No
1,220.
matter well, is anything alive on it or not.
$15.
Well, if you can see 10-kilometer resolution, you'll be
Here's the
able
issue,
to
though.
see if something is purposefully done.
You don't get like internet or anything.
Good job.
Someone told me that at UFA, it comes.
If you can zoom in to 10 kilometers here, you can see stuff.
Yeah.
You can
Yeah,
definitely
water.
see
Yeah,
buildings and
buildings,
cities,
yeah.
The water.
Lights,
streets, you know. 10 kilometers, that's crazy.
Yeah, it would be incredible if it works.
That's
Take the
insane.
elaborate steps to do it, and once you're out there, you're
Fine.
not gonna be able to say,
Yeah,
well,
you
what are
better
we gonna
hope
do?
you don't need to make repairs. It gets out there, it unfolds and something comes loose and you're like, well.
That's kind of what's happening with Webb right now. Like, it's been pummeled by so many space debris.
Aw, man.
Yeah, it's been more than that first one. Keep having to like
They're really quick to
adjust the.
that shit up.
Oh, the power was fine.
Yeah.
That's good.
Like space debris, like
Yeah.
sooner or later we gotta just scoop it up or something.
Government, you know. It's not-
It's about a
You
million
gotta have everything.
kilometers
They
up.
gotta.
Oh, right.
So it would be interplanetary stuff at that point.
Yeah,
We're not going out there.
no.
Just,
I could find them if they live, and I said,
no way.
But I mean, even like with it, like with satellites,
But
like everything that's like
it's much nicer. No offense to UFA.
all the
Much
they're
better.
like,
Pools, amenities, everything.
yeah.
UFA, you get the internet provided.
It's really,
Well,
well,
sucks because
I guess, I don't know what you really could do.
For Webb,
Well, for web, but just space junk in general, like stuff, even stuff that we have.
with China always blowing their satellites up.
If someone like break in, you'd almost have to just like sacrifice a bunch of satellites that we have. and just- But like, I wouldn't even know what measures you could take.
Like, to be honest. the
Even just to
climate
collect
there,
debris, even if you're not worried about like,
You think?
you know, if you accidentally scoop up a working satellite or something.
that water has gates. Also,
But it does, I mean, that's something
however,
They
that
don't take
eventually
your
you'll
internet.
have to
they don't.
figure out.
Let me show you some funny
Unless you
pictures.
figure out a way to never launch or to not create any more space debris, which seems equally unlikely.
Well, what they mostly
This
do
is a
is
picture I found.
It ain't nice.
Pacific Ocean. There's like a spot.
If it loads, let's see.
I don't care.
Sure. They just gotta drop it wherever.
Yeah, it's hit buildings and stuff, you know?
Here we go. This is a funny
And they
picture.
keep testing their
This is a nice
way
picture.
of blowing it up,
Say
like
just
just
because apartments are expensive, you pay a security fee, right? This person parked their car, they went out to the car.
like almost all satellites should have a way to maneuver to a safe rehab.
Expensive.
Yeah.
Security fees, all that stuff, and that happens.
And that means it's a resident.
And then security,
That,
the
that
cameras,
means, that,
cameras don't work.
that means it's a resident.
Yeah.
We don't have cameras. Right. But mind you, the only crime that's committed is to like.
Forgot
buy
you teach
stuff.
school here. Yeah,
It's like, well, it's on at any rate, I guess.
yeah, and so your PowerPoint will be displayed on YouTube Live. Yeah, we're doing it so people that can't make it up here.
It's a resident. It has to be a resident.
Yeah, because people are like, how can an outsider get it easily? I'm the resident, I say, hey, this is the gate code. Whoever has it,
It has to be a resident. Or Uber driver that remembers their code.
Yeah.
Or Uber Eats driver that remembers their code.
so honestly, looking at it, I'd probably go with UFA.
You also have campus
I'd seen them patrol, like they drive in there.
So like, they settle disputes all the time.
Really?
Yeah.
There's a lot of domestic issues.
Like not sometimes they get into it, and they start screaming, and we can, the walls are thin, so we can hear it upstairs. I live on the bottom floor, so like, you know what I mean, I don't wanna.
You can hear them throwing glass bottles at each
Yeah,
other.
you can hear them being like,
My mom warned me about people like you.
quiet up there, Carlos, and they're like.
Yikes. It's scary.
I'll react to it with.
Do any of the like tenants have kids or anything?
Yeah,
You're on the wrong floor.
no, not mine, not mine upstairs in the reserve show, but like,
You got this one?
Can you do, yeah, I don't know, actually, I've never studied.
Oh, yeah, over here then.
Sorry.
not you,
Oh.
sorry, not you,
No,
I didn't mean, I'm sorry.
you're good. We got Cheetos, Doritos, Lay's. Which one would you like?
Sour cream and onion Lay's. Do they have that?
These right here?
Yes.
Yes, they do. Best club ever.
Hey, I mean, we just came from the cybersecurity club, so.
You're making new USB things where it doesn't matter how you plug it in,
Yeah,
because
it's
of the.
great. As a computer science major, yes.
I mean, it just makes sense, right? After so many years of like sticking it in 5 times.
Did you know Mac is going back to the original like dongle, the USB-C? Because people got paid, so they had to pay extra for like the USB-C to like connect the USB regular USB.
Isn't Apple gonna implement USB-C on the new iPhones? Because of the EU, they have that issue.
It's not gonna. Can you imagine?
Apple's not gonna be happy.
No, hell no.
I admit I'm a little bit an Apple fan. Apple's
That's yours?
I also like Apple, but it's getting to the
You know, I
point
posted-
where it's unaffordable.
I'm
Regular.
pretty sure.
They're not very innovative either.
Huh?
They're not very innovative right now.
Like, oh,
Ever since Steve Jobs died,
Alyssa,
it's stagnant.
hers. You know, I posted that in chat, like, hey, if you forgot
I'm
this.
so bored of my phone. I'm thinking about buying an iPhone.
I haven't.
No, it's
Just to relive the nostalgia.
I have an iPhone 1.
You do?
Yeah.
Okay, well,
No,
You should make that your primary phone.
I don't.
Oh.
Yeah, 2 different ones lightly, kind of up to speed on. One was about Artemis, the other one was the Deep Space Telescope. So this one's longer, but has more pictures. And then the gravity lens case that is more innovative, I guess, or something.
More theoretical at this point.
Yeah, I guess that would be one way to describe it. The Artemis story is looking at the mission, but I had a particular slant on it. I'm fascinated by Artemis, by all the details, and contrast and compare. And then now and then, having worked on a little bit on lunar stuff. And then it also was carrying a bunch of CubeSats on it for heliocentric missions and lunar missions. And put together something with my colleagues at the company where we had suggested a way to deliver these ourselves. And we sent it out to NIAC, the NASA Advanced, I guess, group for looking at exploratory missions, I guess, similar to what actually was involved with the deep space missions. Well, we weren't that advanced in our concept. It was just another way to take out CubeSats. But I think one of the reasons we did lose is that it was assumed that Artemis would be doing this routinely. And it isn't going to do it. It didn't do a very good job with the ones it had on board. And then I think they canceled the program after the first flight, saying, well, we're not gonna do this anymore. So I guess got a little grumble there.
Hey, sorry about that.
Oh, yeah, I'm just turn over to you.
Yeah. I'll take it over in just a second. I appreciate it. How's it going, guys? Good. Yeah, pretty good. Long, stressful day.
So just,
Oh, hey, we're live. I'm just giving that out.
I did peek at the YouTube when I was on the way in here.
Hello.
And you can hear somebody over here from that big microphone right
It
there.
would be best if you stand closer to this thing in the center.
Oh,
That's the microphone.
I'll do the monitor, but we didn't see anything else.
Well, sorry I was late. I had to pick up my dog and that took a bit longer than I expected it to. Anyway, today's gonna be a kind of short, little small meeting, mostly just to get things going for the semester. Here on out, from month to month, we're gonna have a weekly kind of schedule. Every Friday, we'll have something going on. Starting next month, on the first Friday, we're gonna have mostly just like a members, officers, little get together kind of thing. On the second Friday of every month, we're gonna head over to LPI for Johnson Space Center's Astronomical Society's meetings. We've been doing that for quite a while and it's been pretty entertaining. They have giveaways and stuff like that, and then like a little meeting after the meeting at Mod Pizza. That's pretty relaxing and enjoyable. There's some NASA employees, stuff like that, that are usually there. Also, on the third week of the month, third Friday of every month, we're gonna be doing something like this. It'll probably be more set up and put together starting next month than this month. We kind of had to do things last minute this month. But this month, we do have some information from internships I'll go over here in a minute. Probably after Dr. Kelly does something, if he has something together. Cool. The fourth week, and if there's a fifth Friday, the fourth Friday and the possible fifth Friday, we're gonna do something special. Next month, we're gonna go to the planetarium, the downtown planetarium. I'm gonna try to set up a fundraiser for next month, the first couple weeks. And then we're gonna try to get government to help fund it, the student government to help fund it. And so that we don't have to have like members buying tickets or anything, that we can just fund it ourselves. Except for transportation, your own transportation, of course. We'll announce more details about that within the next week or two. As well as more details about the upcoming meetings and everything. Other than that, I'd like to pass it over to Dr. Kelly if he wants to go ahead and continue on with his.
well, I'm actually a doctor. I play one.
you're not a doctor?
Well, Professor Kelly then. How's that?
Dr. Kelly this whole time. It's
Yeah,
winning
I've been
here.
referencing you as Dr. Kelly the whole time as well. Which would you prefer? What would you prefer?
Well, presentations,
Yeah, Mr. Kelly,
whatever you
Professor Kelly.
choose. I mean, I can act in that.
You'll always be a
Capacity.
doctor in my heart.
Yeah, before you got an honorary doctor for us. Honorary Dr. Kelly.
I came over with two that I think are in working order. One was about Artemis. I had a particular slide, I was preparing it anyway. And then another one, it just kind of came together in the last 24 hours. So it has a beginning and end, thankfully. And that was about prospects for a microgravity or a gravity lens telescope at great distance from out into the Oort cloud, and explaining how that's supposed to work. It was kind of topical on Satori Dreams. It's kind of a website devoted to interstellar studies, as it were. That one's probably shorter than this one, but if we could pick this one up, it's again sometime if we didn't cover enough tonight.
I did wanna maybe theme next month's around Artemis, so maybe you can save the Artemis one for next month.
Next time? Okay.
Does that sound good? Do you?
Yeah, fine, that's
do the
fine.
other one?
Yeah, it's ready to go.
Well, that works out, huh?
I guess what I should do is first sort of calm down. I was kind of running fast to get over here and prepare all this stuff, especially the other presentation. For those of you who are online, my name is Russ Kelly. I'm the Astronomy Department adjunct instructor. And oh, there it is. Okay, good. And it's the slideshow, so no, that's not where I had mine.
This is the thing at the top that looks like an old projector screen. Very top.
Oh, yeah, that's it.
You're right.
There we go.
You got it.
Right, sometimes I have a few words to say about this, but there's a lot of tie-ins. Some of it is about general relativity and how it got going, and motions of the planets, how some of them don't seem to obey Kepler's laws exactly. And there are explanations for the ones that are outer planets, why they don't do it, but why should Mercury have a problem? That was kind of an enigma in the 19th century. And you might say that some of this story really got started about the same time that Sherlock Holmes is supposedly wandering around. Well, the cast of characters, as it were, say that Sherlock Holmes is played by Albert Einstein. And his Dr. Watson was Sir Arthur Eddington rather than Arthur Conan Doyle. And then another character in this play was the planet Vulcan. And it's not where Spock came from, but it was located in our solar system. And it was supposedly causing Mercury to depart from the laws of Kepler's motion, not necessarily Newton's. Newton's laws of physics or attraction was used to kind of backward derive the presence of another planet that was closer to the sun. It's somehow invisible. And I guess Mercury could say it played itself. And it brings us to, I guess, the title of this thing. It was going to be the spherical lens. And that would be the sun. So a lot of this kind of originated before Einstein and then had all these convolutions to it where we are now. And contemplate the idea of setting up this deep space mission to go out to 550 AUs out and look back toward the sun in order to see something behind it, which sounds ostensibly pretty crazy. And for a long time, there would be discussion on this online. And then I also had the other issue is there are about 4 or 5 methods of detecting exoplanets. And some of them are kind of heritage things like, well, if you have a binary star system, you have ways to detect them either because a bright star is moving around in the celestial sphere, and you can track that in the celestial sphere. That'd be astrometry. And then another method would be the Doppler shift of the lines in the spectrum of a visible star, so that you can see that it's being perturbed by another object that's going around a center of mass. So sometimes the Doppler lines are, as it retreats, are turning red, and then it comes around again and they turn blue. Now, have I missed anything? Oh, yeah, transits. you have a star and you're looking at it, and then, like Venus, an exoplanet might go in front of it because it's in the line of its ecliptic plane, as it were. Plane of orbit is such that it's in the line of sight between you and the star. So it might cross the surface of the star as it is observed from the Earth. And then mysterious fifth one, I believe. I'm losing track of the number here, but that would be microlensing. And it was kind of a dilemma to me to figure out, well, what can I say about microlensing? It sounds so complicated, and it didn't seem to make any sense how we saw anything at all. So that seemed like what it was is that you would get an event where you had a gravitational field of a star distorting space, so the optics of something in the distance got magnified. And that was about all the traction I got on for a while. And I said, well, I'm not going to talk about this in exoplanets. I don't know what I'm doing or saying. So every time it would come up, I just made a little bit more progress in figuring out what was going on. So we could start here. I feel like poking at something, like at the screen. We got the planets of the solar system and how they were obeying Kepler's laws. Period squared divided by the semi-major axis cubed being a constant. And if you use non-dimensional units like years of the Earth and distance in astronomical units, you can get that value to 1, or pretty close to it based on the orbital periods that are observed and the semi-major axes. So you get cases that departing from a value of 1, the Earth does a pretty good job, as does Mars. Jupiter seems like it's a little bit off. But when I guess the disturbances get rather large, there'd be reasons to say, well, why is it doing that? You have cases of Mercury and Pluto. Pluto's a pretty good one too. It's out of alignment as much as, well, there are two things about Pluto. It has eccentricity. It's similar to what Mercury's is. And it also is highly inclined to the ecliptic plane, just like Mercury is. So it's unfortunate it wasn't included in this set, but it also has some bearing on the issue that got people off in the 19th century. In the case of Pluto, it's one of the reasons people are still looking for planet X, because it's perturbed in its trajectory in terms of the Keplerian constant here. And Mercury is as well, but it doesn't have any massive planets in its vicinity. Now, you could say that, well, Jupiter and Saturn interact with each other because they're big and they distort this very simple relationship. And Neptune and Uranus, they would be doing pretty much the same thing. It either could be because of Jupiter and Saturn, or it could be from an object that's deeper in space. But the Planet X one had a resolution. It had 2. One it didn't work out so well, and then the second one seems to explain things rather well. Just there's a little bit more detail here, but the eccentricity and well, I guess these two things were noted for the astronomy class, and here's a little bit more background on the calculations. The perihelion and aphelion, you can figure that based on the eccentricity. And circumference and period. If you're going around in a circular path, or else in a semi-major axis path, then it's equivalent to a circular path in terms of calculating the period. It would be your effective velocity could be computed by the circumference of the circle and the period of time it takes to go around there. And any of the variations in the period at perihelion and aphelion down here. So what alarmed people in the 19th century was not the period relationship, the Keplerian constant there so much as the advance of the so-called ascending node. Now, if we take the Earth as an example and say it's in the ecliptic plane, then our inclination is 0. And a lot of these things you don't really count very much. But if you have other objects that are moving at an inclination to the ecliptic plane, such as Mercury, there is a certain advance associated with it, and taking into account how more than 2 bodies considered. Say if you have a third body, then these third bodies are all the other bodies in the solar system are causing some sort of disturbance to what you would expect these angular rates to proceed at. I guess they actually need more than 2 bodies. At 2 bodies, I don't think there'd be any advance at all. Just the say the Earth and a satellite, for example, and the Earth was a perfect spherical body which had no blightness. But since there are other things that are perturbing these orbits, Mercury was the one that really stood out by advancing faster than the other ones. I mean, it was expected to have some advance in that ascending node going around the sun over a period of years. But all the mathematicians of the 19th century just couldn't explain part of that. And they figured they could explain the other ones. I mean, they'd be ciphering away, to calculate to the last decimal point they could. So what was proposed, as you might suspect, and let's see, skip something here. Well, I guess all this is the particular values for all these properties of the solar system planets. They're in columns here, Mercury through Pluto. Pluto made it on this one. And then you have the longitude, the ascending node, but it doesn't give the rate here, I don't think. But this would be advancing over a century faster than it should in that red column there, or red column, the row. So it's only the Sun and Venus is its immediate neighbors. Mercury was moving it faster than it should. So if you look up Wikipedia, there's a detailed article on Vulcan. It doesn't talk very much about Spock and his clan, but it does talk about this object that was inside Mercury's orbit, and it was so many people were convinced that it existed, is that many people that were, well, they simply said, I got it, I observed it. And for a while, I suppose a lot of the literature, maybe even textbooks, probably had it as a feature of the solar system. And some of these astronomers are fairly accomplished. I think Verrier, they performed this type of calculation before, for instance, for asteroids, figuring that not Mars, but Jupiter was responsible for a lot of their departures from Keplerian orbits. So you can see that a little bit more detailed. It's figured to be about 16 million. I suspect that's kilometers, even back then. No, that looks like that's miles. I guess the Earth being statute miles would be about 92, 93 million. So that would be about 16 million miles from the sun. Well, that, in a way, I guess, was one of the many reasons that Einstein, circa 1905, started looking at special relativity and general relativity. And by the end of World War I, he had this pretty well worked out. And as a result, there was, I guess, in the astronomical community where people were starting to say, all right, Einstein, I see what you're trying to say. Now, can we prove this in any way? And it was proposed that, well, let's set up during an eclipse of a pretty bright star. we know where its position is, should be, and before the sun is in its alignment with it. So it goes into eclipse, and then it comes out, and what is its position going to be? So if the star behaves in a way, or shall we say the light behaves in a way that would be obeying the laws of Newton, the photons moving at 300,000 kilometers a second would approach the sun and be deflected according to Newton's laws. And, or like other bodies with mass. But if they didn't, then they might be attributed to things that Einstein had derived. And by that time, he had a comprehensive general relativity picture of things rather than just special relativity. And say if something came in, well, it looks like there's some stars identified there. You see them just faintly. 65 Tauri, for example, and 67 in HR 1403. I'm not sure if any of those are the ones that are under discussion right now, but if one peeped out there and was not in the position that was predicted, then Einstein had a case. Well, it was there were several attempts to do this, some several years apart. I guess some of the parties that were trying to do this got caught up in World War I. They go off into, I guess, the Tsarist Russia somewhere, and originating in Germany, and then they had to sit out the war, I guess, in an internment camp. And I don't think they got any data back. But there were several expeditions that were sent on a subsequent eclipse opportunity for some stars that looked like they would pass behind the sun in appropriate positions that could be predicted and observed. The trick is you had to go down into, I guess, the southern hemisphere, somewhere along here. And I don't think they're called out on this particular map. This gives you the track at any rate to the locations of the two. See, did I skip over that? Well, let's try this at any rate. There's predicted arc-second advance, 0.1 arc-second advance of Mercury's perihelion each orbital revolution, or 43 arc-seconds per century. That was how small this perturbation was. And the theory did not use the hypothetical Vulcan. It's trying to get rid of that. You can't see it unless it's an invisible planet. If it has a mass, then we need something else to explain this. And another reason all the focus was on Mercury is that it had some eccentricity, so it had an identifiable perihelion. And Venus, for example, it did not. I mean, it's nearly a circular orbit. So it's in a noise level where the perihelion is on Venus. And so you could just forget about the general relativity application, at least at that early day. Well, I guess Eddington was already, I guess, an astronomer of some repute at Cambridge, I believe. And he took the Einstein's theory very seriously and became one of the well-known experts on it at the turn of the century, or well, in the 20s, as it were. And there were two expeditions that were sent out. He was on one of them. And let's see if I can identify the 1919 results. This was for the 29th of May. Am I going around in circles? Well, let's see, we put it like this. What could we be expected to see is that the photon might just go in a straight line and not be deflected by the sun at all. Would be one possibility, since it doesn't have any mass. And then another one would be it behaves like a bullet that's deflected by the sun. And then the other would be that it adheres to this new theory. So what were the effects that were actually observed? Well, I guess I've got some of the background that I was trying to find originally, I guess. Who went where? Einstein had updated his prediction on this, so I guess he hedged a little bit too. He got some help from Carl Schwarzschild. I guess he was an astronomer. His son actually worked at Princeton, pretty much in the same field, astrophysics. And Carl Schwarzschild, yes. And he was I guess, interested in this subject as well. I think he was the originator of the Schwarzschild radius of black holes, for example, saying where you would cross the event horizon is associated with his name. So here's the net of it, I guess the basics of it. The deflection was based on the gravitational mass times 4, and then there is the speed of light and a parameter b, which would be pretty much akin to, say, the perihelion, or point of closest approach of the light. Now this gets kind of complicated if space is being distorted. But the bottom line is, in the case that they were looking at, they expected a deflection that would be 1.75 arc seconds, which is pretty tough to, even now, I guess, to identify, and especially out in the field. If you're working on some tropical island, the weather's bad, the seeing is bad, and your magnification is poor. So the original results are pretty ambiguous, but they were close enough that it was generally conceded that he was right. And I think when the results were reported in English, like they were, or I mean in Europe, at several conferences, I think they were standing ovations when it was discovered. He did receive a Nobel Prize or two, but in 1921 it was not for his general relativity work. I think it was for Brownian motion. So what are the consequences of this 1.75 arc seconds? That gets us to some more recent developments, kind of skipping about 100 years, really. If the sun deflects distant starlight by 1.75 arc seconds, and that means that all this starlight coming around the sun is being focused somewhere. And since the sun is about 700,000 kilometers in radius, if you extrapolate how long that baseline is, that with that subtending an angle like that, it goes out to about 550 AUs. And when I did that calculation here, I thought, well, gee, that sounds familiar. That's what these people are talking about for these gravity lens telescopes. It's all starting to fall together. So you could say that this creates a primary lens for a rather unwieldy telescope. And then if you have, this is a primary lens and you have a secondary lens, you're not going to build it this big. You're not going to have an optical length that long, so the magnification would be enormous. Yes, sir.
So we're going to use our sun as the primary lens or the planet, the other planets?
Well, I'll put it like this. The sun would be the lens that would bend light, but you're looking for a planet.
Our sun.
Yes.
Oh,
I mean, you could do variations on this. And as a matter of fact, I think that's how a lot of gravitational lens actually works, is that other stars are doing this for us. And then every once in a while in cosmic distance, a planet will wander into the frame. And the mystery of this is how big is a frame? I don't understand that part at all. still trying to figure that one out. But in this case, you have the sun standing in the way, and you're looking at the back of its head, where there's a star, and then around the star, there might be a planet. And then if you know where the star is, and you have a second source of observation, say another observatory, maybe on the Earth, and you know exactly where in the celestial sphere that star is and where the planet is, you can send a signal out to observers 550 AUs out there, say, move over just a little bit so you can see that planet. Or at least you're focused more on it than you were before. So as I was saying before, I guess we got started. There are 4 principal methods for observing exoplanets. And it's kind of derivative of existing astronomical procedures for binary systems. Maybe you have a bright star and a less bright star, like Sirius has a white dwarf going around it. And that wasn't observed originally, but a case was made for it by, say, things like Sirius's motion in the celestial sphere had to be doing it some reason. It was going back and forth like this. And then there would be spectral line shifts, red and blue, for if you looked at particular discrete lines in its spectrum, either emission or absorption. So that would be due to its Doppler effect of it going back and forth like this. And then a whole lot of other stars are like that. So originally they talk about visual binaries where there's separation that can be resolved, and then spectral binaries where you just look at these lines that are shifting back and forth. It seems like they're independent sources. But spectral binaries, if you build a bigger and bigger telescope on Earth or in space, eventually they become visual binaries. So it's not some inherent property of them, but the telescopes themselves. Then there's transits. Transits across the front. I mean, you say Venus doesn't do it very often. There's so many geometrical issues and little variations in the orbital plane, and the sun only being about from the Earth a half a degree wide. So if you have a half degree or more, maybe a couple of degrees there in the ecliptic plane, there would be a whole lot of instances where Mercury and Venus would not be lined up with the Earth. So you got to wait for a century or two for them to be in a line, I think, with Venus. And Mercury, it's a little more often. So it goes around faster, too. So the 5th method would be microlensing, and I think what it really tells people is that there are planets out there, all right. And then when you look at all the statistics involved of having a gravitational lens with one star, and then having something wander into that gravitational lens field, you get some notion of how frequently planets form, I guess, in other star systems. But the deriving that would be kind of, I'll let somebody else do that. Where I got involved in some discussion about this over the years, this site, centaurydreams.org, it examines a whole lot of things that are related to travel in interstellar space, but I think what bottom line really, it just goes back to astronomical issues such as this. So this was a recent article around February 8th. Paul Gilster was, well, he has a way to just go through the literature and publications and find it and bring it to the website. And most of the things that are attached to these articles you can download free. They're open journals or preprints or whatever the case might be. So it's a cheap way to do your research rather than buying a journal. I guess subscription. That it really gets expensive fast. As soon as you buy one, it's where the good articles in the other one. So there is a, well, actually, it's the AIAA that published this article, the Journal of Spacecraft and Rockets, or the Guidance and Control, I forget, one of the two of the aerospace journal. And what it is I guess, a study of how to deliver a telescope or two, about 1 meter aperture, out to this point. So it dwells mainly on the delivery of the system, and it might take years to get it out there, right? Well, no if about it. It's going to take years if they set off on this voyage at all. Because it's further out than, say, any of the Pioneer Voyagers have reached space, so they'd have to speed things up with more energy in the delivery system. And the article is described in, or I guess this is just the abstract of the paper, going out to about 550 astronomical units and how it can be done. And this was a sponsored study by NASA, I guess, Advanced Initiatives, I believe, or Concepts Office. The optics look something like this. And this intermediate step, the coronagraph, basically what it's doing is blocking out the sun. So you know about how far out you're going to be and how much of it you're going to need to block. So what you're really looking for is the light that's going around the sun at the edges. Yes? Did somebody have a question?
I'm sorry.
Oh, sorry. And so it'd be almost like a corona. Now, I presume, I haven't been able to derive this myself, I just figure that it's the next step to understanding the system. Say if you had a point source of light behind the sun, then you'd want to focus on it. You want to maneuver around, slew the spacecraft, so it was in the center of the back of the sun. And then all this light that was associated with that point source would be traveling along this line described by so far, and then it would be bent around the sun, focused. But I think you would, rather than focus on the star, if you want to look at the planet, you aim at the planet. So if you had a planet like the Earth, and it's 10 parsecs away, field of view would be about 17 or 17 astronomical units wide. Due to, I think I can explain it in the next few slides, but you don't have all night here. And I guess we're really looking at two things, because you have the light from a particular point source in the background where you slew around, and it gets around the coronagraph that's blocking the sun, and then you have to interpret it somehow. And I'll do some hand waving, say that it's by some sort of convolution or some other mathematical expression, Fourier analysis or something, you get a picture of a globe. And that's the whole objective. And there are rumors or assertions, I guess, that you could get a terrestrial object down to 10-kilometer resolution. So you could get a lot of features out of that. And one problem with this is that if you got a 17 astronomical unit, go back that a little later. This is something akin to what might be happening. You get an object like this, and there would be this might be your initial data, and then there's some sort of transformation you could do, massage the information from the light source, and get a picture of something like that. Clouds, green, in that case, if I'm looking at the Earth, somebody's already doing that to us. I had some correspondence on the website. Nobody's really arguing with this too much. So if you're looking at something at 10 parsecs distance, then the field of view, I think, would be the radial distance in the field of view behind the sun would be about 17 astronomical units wide. And then if you're interested in the Earth, it'd be one astronomical unit that you got to find in there somewhere, and it's wandering around the sun. So some other observer's got to know exactly where it is with respect to that sun. And then if you're out at this distance, you have to slew around at 550 AUs, the corresponding angle. Now, it's not very big angle in terms of degrees. It's arc seconds, but a circle that big is pretty big. So the magnitude of, say, the Earth going around at that distance is about 400,000 kilometers amplitude, if it's projected this way. And I guess maybe half a year, you'd have to go over 400,000 kilometers this way, and then 400,000 back. It's sort of like going to the moon and back. And you better have some propellant to do that, or some means to do it, to keep up with the Earth. Or you could carry more than one telescope. You could deploy them earlier if you're anticipating all this.
Sorry.
Go ahead.
Would the secondary, whatever you call it, that's way out there in space, would that
So the
have,
secondary lens?
well, yeah, the one with the chronograph and the
Oh, yeah.
sensor,
So,
the one that's 550 AUs away?
Yeah.
Would that just be like in a I guess you would call it heliocentric orbit, where it just,
well, I
would it
guess
have
it
to
could be either
in
way.
an orbit? It'd have to orbit.
I think asymptotically, it could be just heading out on a line, a sight. It doesn't necessarily have to remain at 550 AUs, because you could go further and the system would still work. Like there's anticipating going as far as 900 AUs for some reason.
Would they be able to like stop it though from work, you know what I'm saying? Because it'd have to be solar powered or something, I'm assuming.
Well, even as solar powered, you don't get much solar power out there. There are some issues there. I mean, I could, a couple of things I could top of my head, but other ones I don't have the slightest idea.
I know, like the Voyagers, we lost control of
Oh,
their
really?
direction a long time ago. I know it's like 70s technology, but
Oh, yeah. Well, you say if the report tells a little bit about different propulsion systems that can be used, and then you're going out on an asymptotic, what would you call it? I guess a hyperbolic path in this case. So you're asymptotically going off to a certain line associated to hyperbola. But you'd still have the issue of if you want to point at an object that's behind the sun, you have to have tight control on what angle you are at to get that star. So that would be a propulsion loss. You might need something like electric propulsion with a nuclear source, be one possibility. And then if you want to do this multiple times, you still have to have some reserves to go to the next target. So there's 400,000 miles to just keep, or kilometers to keep track of this one planet that you think is a really hot item that you want to investigate further. There might be, say, 50 that fall into that identification, but they might be all over the sky. As an illustration, shall we say. I don't know if an arrow would do any better. So the sun's in front, and there's a field behind it that is about 17 AUs wide, and then there's a star that's in the center of it, presumably. And then there's a planet going around in some arbitrary manner. And the planet isn't going to be this big. I don't think it's going to be satisfactory just to leave things as they are and say collect all the light associated with this field of view. I suspect that you're going to have to focus on that object, which is a lot smaller. 100th the radius of the Earth, 100th the radius of the sun, shall we say. And then it's in the center, and then there's assumption that it isn't going to be something being clipped off when you do this magnification. I don't know how big the field of view is. Nothing I know so far explains just how wide that image is there. And then the sun, you could consider something like a field of blockage, and this would be the field of view behind it. And then if you got something here, you'd want to slew over to that point. And if that was at its maximum elongation from the sun, that would be about 400,000 kilometers. If it's projected in such a way. And then if it's in plane, it would just be zigzagging like this, but then it might have some offset too, as it's going between the two extremes. So some of this can be established before you get there. And then still that would be arc-second precision to get that thing into the center of the field. And in the case of the Earth, it's something like 1/10,000th of an AU wide. If I got that right. Well, I guess that part I could leave, leave on file. I'll tie you up all night with this. But that's essentially one presentation anyway. And
That was great.
Yeah.
I got my brain just like
Yeah.
thinking about.
you better take that down.
What if the sun shrinks? How much does the sun shrink?
Remind you.
Everybody's not gonna lie. It's something like, it would take 2,100 some, I forget what the calculation was, maybe.
Thank you, Kelly. So
It would
next
take like
week,
2,000 years to shrink.
next Friday, we're gonna try to set up a movie night. That's gonna be in this room, starting at 7:30. I'll probably put a poll in the Discord to see what movie most people would be interested in. It'll be based around space. It'll probably be involving like bad physics or bad space logic in some way.
Star Trek.
We did a couple of bad ones already. We can do a good one.
You gotta balance out the gravity.
What's the movie in the poll? What about Arrival?
Arrival.
Whole series.
Oh, yeah, I've seen Arrival. Yeah, that could be the good movie. I'll put a good movie in the list. We'll see what people vote on.
Oh, Interstellar.
But other than that, there's some internships that I recently learned about. One that some of us might be already aware about is one by LPI. They're doing some examining on the lunar surface. So they're looking for like earth scientists, material science, stuff like that. It pays pretty well actually. And it's very local. It's right next door. So I'll be putting some more information about that in Discord. Jacobs down the street is also hiring. This is open to most STEM majors, including like IT, software, all that kind of stuff. I was definitely looking for this one myself as well. They pay very well. They have great benefits, all that, flexible schedules. They're hiring internships and full-time if you're looking for a job. There's also SAIC, who's nearby. They're working with NASA and Johnson Space Center with their safety and mission assurance engineering contract. They're also hiring full-time or interns of all kinds, so like software to like physics, mathematics, all that kind of stuff. Next month, Axiom Space is going to be on campus on March 22nd. They're going to be doing some panels about their internships and stuff. They're working with the ISS. They're actually going to launch their own space center. They're going to launch their own space station starting in like 2025, I think. It's going to be like a commercial privatized space station, which is very interesting.
Because they're about to crash the space
I
station
know.
into Earth.
They're attaching something, I think, at the end of the year to the current space station. Yeah. It's kind of falling apart. Other than that, if you're interested, we are going to be going to the planetarium next month as well. A couple days after Axiom Space is here on the 24th, we'll be going. I'll start laying out more details about that in Discord and everything, and it'll be on Get Involved. We'll do a whole campus-wide push for it and all that. See if we get a lot of people interested. Other than that, I don't have much else to cover unless someone else wants to bring up anything.
Just started one thing, Probably roughly, I'm not sure if it's at the midterm break or not, but the Lunar and Planetary Science Conference is something. The Woodlands.
Oh, so
Now, they do have a website.
What was it called? The Lunar Planetary Science Convention?
Yeah, Lunar and Planetary Science Conference. So it's huge. And they do have, at the very least, the website is open now. You can look at the abstracts that'll be presented there. And in the past, what they used to do is to have 2 nights poster
Bring it up on the screen.
Oh, I can, yeah.
poster sessions.
It's March 13th to March 17th.
How does that coincide with break?
Break is March 10th to the 19th. Well, 10th for me, because I don't have class.
So it's lining up with the.
Oh, that's great, yeah.
Whoa.
So the Lunar and Planetary Science Conference. That actually looks really interesting.
You can't drive there, then there's always the stuff that's online. It's a huge collection.
So it'll be virtual and in person?
Yeah. Or at least the posters and the abstracts are. The other parts of it, I'm not sure. Some things might be online, presentations or talks.
Well, there's something we can also
It's
look forward to.
expensive to go to this actual thing, right? But don't they have something where it's open to the public?
Yeah, in the past, it would be Tuesdays and Thursdays, so usually in the evening or, times I've gone up there, I've arrived early and just wandered around at the
You're looking at,
exhibits.
you're looking at the 2021 one.
2023.
Oh.
Happy New Year. But those are accessible too. If there's anything you see that's associated with the previous ones, you can pull them down and they're usually 2-page summaries of work somebody's done. And if you're thinking about working for the LPI, it is no, it's to your advantage to look at that stuff. Gives you an idea what goes on.
Well, yeah, we'll look into that and see if it's affordable, maybe we can set up something for that. That'd be cool to get our group going.
looks like it says $250 a night. Oh, plus fees and taxes. Yeah.
That's the room rate.
Yeah, I guess the key is poster sessions at any rate. It used to be
Oh, that's
free.
for a room. I mean, that's to have a booth, then we don't need a room, you know, that's true.
Yeah, I looked it up last year. It was like $350.
That's all? Well, I thought that, I don't know, to me, it seems like that includes like a room if you're staying, you mean, right? Like versus just traveling.
Say if you're going to a conference and attending the oral sessions, then that would be,
The recent space educators conference, that was like $250 just for the ticket.
Really? Okay, yeah.
Yeah.
Jeez.
And that is like for Zoom. Like if you want to attend our Zoom meeting, it's like that.
Yeah, that's true. That was just the virtual ticket. The in-person was like,
I guess.
Tuesdays and Thursdays, I think, are the times you can just go in there and look at all the exhibits for free.
Sure.
And then the presenters are often there defending or trying to explain what it was all about.
Really see or know where this would be for how much it costs.
Maybe
For like-
in the store.
in the store. Yeah.
Pre-COVID, that's how they operated.
Yeah. Unless it's just t-shirts and stuff.
Onesies.
Nice.
The onesies.
We'll figure that out
Yeah,
later.
we'll figure it out.
Masood still has her seminar things go on a semi-regular basis. So Monday, there's a speaker from Rice that's doing a talk on buckling of semi-flexible filaments. So if that's
Some materials
random,
and stuff.
yeah, so she'll have people come in on random topics, usually so that other people can do their research on it.
I feel where she still doesn't
Mondays
organize
at
it.
what time?
Monday at 7. There'll be a Zoom link, huh?
Every Monday during the semester?
Usually, I wanna say, but then like, things are flexible depending on the presenters, if they drop or things like that.
Schedule in the Universe.
Maybe. I'll have to ask her. No, right. Last year there was a schedule, but again, I don't remember how often it's done.
I heard about it. They're like, it's going on in 10 minutes. I'm like,
Do you meet with her fairly often?
Yeah, I still have a class with her, so I'll hear about things like that every
Class, okay, she still doesn't recognize me. I saw her, like, I waved at her and everything, and she just, like, walked away, so I'm like, I need to meet with someone that knows her, and then just be like, hey, this is him.
I can be the liaison between any of the student interactions.
That'd be nice.
But yeah, so it's usually Mondays at 7 when she does have a speaker. I don't know about the week after that or anything yet, but there's usually a weekly person coming in. There's usually a Zoom link as well.
Is it in 1203?
Yeah, that big lecture room usually, yeah.
We're gonna make a mention real quick. I found the prices. So there's the in-person registration fee. If you do it early, which is all the way up until the 24th of February, so there's time. As a student, it is $490. However, from the 25th of February all the way until March 17th, it is $525. Now, if you don't want to go over there, there's the virtual registration fee, which early through the 24th of February, so there's still time, is only $290. Now from February 25th until the
Wait,
17th
it's
of
virtual,
March.
right? If we
Yeah,
have
virtual.
one ticket and we just streamed it to.
That is technically
Right?
true.
So I mean,
Split it.
we just
You just have to make sure.
Charging that much, I expect them to do a webcam check.
You can get that money from the SGA.
Yeah.
They only cover like half of it.
Yeah, but we can get it from the department
Oh, get their
And then
half,
get
their half,
refunded.
you could try.
Just have everyone hide out of view from the
That's feasible.
webcam.
Right, like we just get the one ticket and then we just all mooch off that same ticket. I mean,
That's a freaking great idea.
I don't know, I wanna do the webcam check.
real quick.
Now, is that for a day? Like for a,
I
because
don't
it's a
know.
multi-day
Right,
thing.
And then there's still the possibility that they have the poster sessions that you can go to
Yeah.
Tuesdays and Thursdays. And if that's still free, then that's worth it.
Oh, yeah.
We should do that as a group.
Yeah.
I mean, we already go over there for the JCS stuff.
Go check it out.
Tuesdays and Thursdays, so we have classes. What time do you? are they? Well, there's
Well,
like.
that would be the break period, right?
Or no, the Tuesdays and Thursdays.
Yeah, the conference runs from Monday to Friday.
Oh, okay.
And then Tuesdays and Thursdays,
And
and
like
like
Tuesdays and Thursdays all semester.
Oh, no.
No.
Just those nights.
So that's during the break. We won't have class.
Yeah. And they're not gonna go in there, well, if it's like the old days, they don't police it. They just invite everybody in to look at the posters.
Plus, we could tug on on Grace or something. We could reach out to Grace and see what.
yeah, maybe
Yeah.
Grace could.
LPI badges.
Yeah, it's
Even if she didn't, what if we just all got a bunch of lanyards and placards and just walked in like we
I
own
mean,
the
they
place?
have merch there. We can just slap one of those on.
Has our logo on it.
Get in anywhere.
Before we start conspiring crimes, we are still live.
Hypothetically, this is something.
Bring your camera, just be like, press, sorry.
We're with the signal, yeah.
Yeah, exactly, done, fixed.
There are officer positions available as well, like outreach manager. We're looking for a social media person. There's some chairs for like astronomy and physics if you're more into astronomy or physics and would like to do like
Treasurer,
stuff like that. You are currently are still the treasurer.
free to take it if they want to. Sorry, I've been really quiet this winter.
Well, if anybody wants to be treasurer, that could be open for you as well. There's plenty of officer positions. I'll post about that in Discord as well. And other than that, I guess that's it for the meeting. We'll probably hang around and talk and all that for a while. You're the one controlling it. You shut it off. Or-
No, I'm giving full reins over.
Where am I gonna go? I wanna go.
It's a good tunnel.
Bye.
All that time.